Hello, my name is Daniel Green, and today we're going to learn how to use Autodesk's free 2D CNC mill toolpath generation tool, which is an add-in for Solidworks, in order to generate toolpaths for cutting aluminum plates. The free software from Autodesk is called HMSXpress. Now, it is free to download with a simple registration as seen here. The download should be rather straightforward and short. Once done, it will come up in the Add-ins tab in Solidworks, as shown here. An additional piece of software that will be required is the Universal Gcode sender. This will interface your Gcode to your actual machine when sent by a computer. The download can be found here, and ensure that you choose a 1.019 or above version. Do not choose a nightly build, as these are in a beta stage and rather unstable. Now that we have all the required software, let's look into Solidworks how we would begin to generate these cuts. I have created a simple part file that will be used for this tutorial. This part file has a circular cut, square cut, and slot. Unfortunately, this part cannot be machined as seen here. Instead, this part will be machined from a somewhat larger plate, allowing for some material to remain, acting as tabs between the large plate and this cutout. This ensures that the plate does not eject from the cutting mill until an operator has manually removed it. In addition, the corners of this square cut, as well as similar corners in the outline cut, will be rounded due to the machine having a certain radius on its tool bit. The stock plate that this would be cut from would look like this, as well as having some of the outlines for the cuts to give you an idea of where they would be on the stock. Now that we have looked at all of the different cuts that we would be creating for this part, let's look into how they would be implemented in the HMSXpress software. This software can be found in this tab of Solidworks once it has been added into Solidworks. To begin, select Job. Job is where you orientate your stock in reference to your tooling bit. In addition, you can zero your tooling bit from this menu. In order to re-zero your tooling bit, you must go to Fixture and select a new form of referencing. I suggest Z-axis and X-axis. Select your Z-axis as the top of your stock and the X-axis as the right-hand side. In addition, you must choose what point your zero will be at. I recommend top corner 2. Now you can simply zero by touching the tool bit to the X and Y axis instead of having to measure to the center of the part. Once you have completed these steps, simply hit the check mark. Now that we have a frame of reference for our tool paths, we must construct a tool. Choose Tool Library, then New Mill Tool. There are a lot of different properties here. Most of them can be ignored. However, you should look at your tool to ensure how many flutes it has. The spindle rate does not matter, neither does cutting, lead in, lead out, ramp, etc. speeds, since these can be set on the Universal Gcode sender. Instead, we should move to the Cutter tab and choose the proper diameter for our cutter. We will be using a 1/4 inch cutter for our operations today. Now, the body length and overall length do not matter too much. All they care for is if you will be plunging too deep into material. Since we will be using this for aluminum plates and they only go to about 0.1 inches in depth, this does not matter for our operations. Once done and ensuring you have a flat mill, click OK and then OK once more. Now you should have a tool in your tool library. Now that we have a tool in our tool library, let's create some tool paths. The first path I will create will be the circular and square cutouts. This path will be generated by using the 2D pocket. First, choose the tool we have just created. In the next tab, we will be selecting which components of the part will need this cut. For our purposes, it will be the circular and square cutouts. Ignore all other inputs for this menu since they do not matter for most parts. Moving to the next tab, we have how far and how deep these cuts will be made. In addition, we have clearance for our tooling bits. This means how far off the stock will our bits be at certain points of the operation. For example, the clearance height is how far above the part the bit will initially move. The retract height will be how far it moves up to once done with a certain cut. Feed height will be when the tool begins to spin up and begin a cut. And the top and bottom of a cut are as shown here in blue. For our purposes, all of these are fine where they are. Moving to the next tab, we have options focused on how the passes for each section of a cut will be completed. Most of these do not need to be changed. However, you should change to conventional milling and ensure you have multiple depths on your cut. This ensures that not all of the material is cut at once, and for our bit, we should be using 1/10 of diameter for the cut depth, which is 0.025 inches. This additional cutting depth is for a finishing step, which we most likely will not be using. Also, ensure that no stock is left behind. Moving to the final tab, we have how the mill bit will begin a cut. In this tab, there are several different options. However, most of them should be checked off, meaning turn off all lead and transitions and change your ramp to a plunge. This is a simple, clean way of beginning a cut. Once selected, this cut has been completed and can be okayed. Moving to our next cut, we will be choosing a slot cut. This menu will remain the same. We will choose this as our cutting section. This, once again, will remain the same. This will do not need multiple depths, as you will see how the cut is created, and all of this should be fine. As you can see, there's a ramp to this cut, which is why we do not need multiple depths. The second half of this cut will be an augmented 2D contour cut. First, we will select the upper section of the trace. Ensure that the arrow is on the inside of the blue. Then we will change the bottom from the contour to the top of the tab. In addition, we do not need any multiple depths since we will be cutting such a small piece of material, but ensure all lead in and lead outs have been deselected. And now all cuts for this part have been completed. Now that we have completed all of the cuts, we must post-process them into Gcode. To do this, simply right-click on the cut and click Post-Process. In the configuration folder should be placed the post folder, which is a subfolder of the HMSXpress files. This should be found wherever you have installed HMSXpress. In addition, make sure in the drop-down menu you have selected Carbide 3D GRBL. This is the post-processing subroutines that are compatible with the Shapehoku. In addition, your output folder should be where you want to place your output files. You may choose whichever folder you prefer. Finally, choose a program name and then save. Once done saving, Autodesk will pop up your Gcode to allow you to review it. If you do not wish to review it, simply close out. To post-process multiple cuts at once, simply highlight them all and right-click in Post-Process, or click on the job, right-click and click Post-Process All. It has the exact same configurations and saving as post-processing a single file. An additional step that can be done is the Simulate step. right-click on a cut and choose Simulate. This allows you to see what a cutter would be doing in real time to create this cut. Once reviewed, simply hit OK. Now that we have created our G-code, we may move on to the final step of the process, sending the G-code to our CNC mill for the cutting operations to occur. We will be using the Universal G-code sender, as mentioned earlier in this video, to accomplish this task. Once you have the Universal G-code sender installed, open it, and look at your ports. Your CNC mill should be connected via USB to your computer and show up in the Ports tab. Additionally, ensure you change your baud rate to 115200. This is what the Sheipoku uses to communicate with Universal G-code sender. Once the baud rate is set, move to the Machine Control tab so that you may manually move your CNC mill into the 0 position. This 0 position should be the same as the 0 position you placed on the working part in Solidworks. Be advised that this is the work position 0, not the machine position 0. The machine position 0 is set whenever you turn on the machine or connect it via baud or port. To 0 a machine, simply move the machine's bit in the Y, X, or Z axis until it makes connection with material. Once it has made connection with material, reset that axis, and now you will be 1 tool radius away from 0 in that axis. Do this for all 3 axes. Now move it to that position, then move the X and Y position 1 tool radius towards the part. You will now be at the correct 0 position. Ensure that your firmware matches the post-processing type that you used for your cuts. Additional setup can be done in settings and pendant depending on if you need to change your feeds and speeds for your mill. If not, simply move to the file mode and choose Browse. Navigate to the G-code that you wish to use and select it. Once done, you may visualize the G-code, which is somewhat like the simulate visualization in Solidworks, or hit send, which will begin the cut running on the mill. At any time during the cut can be paused, which will stop the machine from moving, or canceled. Be warned that canceled can take several additional steps of G-code before it will actually stop. This can cause problems if you are running into a part already and need an immediate stop of your CNC mill. If that is the case, hardware stops such as power off or motor turn off may be better than the cancel button. This concludes this tutorial on walking through step by step how to take a Solidworks file to G-code and then send that G-code to a CNC mill, most likely a Sheipoku for these circumstances. It should be stated that additional tweaks to feeds and speeds will most likely be necessary after your initial cut to ensure that your cutting tool is cutting properly at a safe depth, as well as cutting quickly enough to ensure you do not overheat the bit or the part. Thank you very much for watching.